Okay, today we're going to continue talking about precipitation titration that we didn't finish last lecture. We said that for a titration, for a precipitation titration, for example, if you have an iodide ion in solution, you can use silver ion as a titrant to precipitate with the iodide. And the equivalence point will be that all the iodide in the solution are precipitated with silver ion from your titrant, right? And for precipitation titration, we normally will be using potentiometric method to monitor the concentration of the titrant in your solution so that you can figure out where the equivalence point is. And to be able to use that method, we have to understand how the concentration of the titrant is related to the process of the precipitation, okay? So that is converted to a question that how do you calculate the concentration of your titrant? In our example, it is the silver ion. So how do you calculate the concentration of the silver ion at different stage of your titration? We can divide them to 3 different stages, before equivalence point, at the equivalence point, and after the equivalence point, right? We know that before equivalence point, we don't have enough titrant added, so you will have excess analyte in your solution. And to be able to calculate the titrant, silver ion, you will have to calculate the analyte first. Now you might be asking, since we don't add enough titrant like the silver ion, how can you still have silver ion in the solution? So that involves equilibrium, right? Equilibrium between the precipitate and the ions. Even though all the silver ions reacted with iodide and precipitate, but that insoluble precipitate still establish an equilibrium between the solutions. So there is still some amount of silver ion present in the solution. It's very low amount, but there is still some amount, okay? So to answer the question, you will have to calculate the concentration of the analyte first. It is calculated by the original concentration of the analyte multiplied by the fraction remaining and the dilution factor. Okay, we will come back to this to explain each component, but let's finish the whole different stages first. And then after you know the concentration of the analyte, you can calculate the concentration of the titrant, for example, silver ion, by using the solubility product, okay? At equivalence point, it is relatively easy because all the analyte are being reacted with all the titrant. So theoretically, all of them go into the precipitate, but then equilibrium will be established. So a little bit amount of the precipitate will go back to the solution to establish the equilibrium between the solid and the ions, right? So we can calculate the concentration of both reactants by the solubility product. Now, after the equivalence point means that all the analyte, iodide ion in this case, has been reacted. So if you keep adding more and more silver ion, you will have excess amount of titrant. So you have excess titrant, and the concentration of the titrant can be calculated by original concentration of the titrant multiplied by volume in excess divided by total volume, okay? And then if you still want to calculate the concentration of analyte, you can use the concentration of titrant and the KSP, okay? Now, let's go back to the first case. In our reaction, again, it's the silver ion as the titrant and the analyte is iodide. So you form the precipitate, which is silver iodide. The KSP here is, let me see, KSP is 8.3 times 10 to the negative 17. Okay, so it's a very insoluble compound. All right, so what does it mean by fraction of remaining. For example, in this case, it is a 1-to-1 ratio, right? So for 1 mole of iodide, you will need 1 mole of silver ion. And if I give you the concentration of the analyte, the volume of the solution, and I give you the concentration of silver ion solution, you should be able to calculate how much silver solution is needed for finishing the titration, right? So for example, if my iodide is 0.100 molarity and the volume is 10 milliliter, okay, this is iodide. And my silver solution is also 0.100 molarity. How much silver solution is needed to reach the equivalence point? Anyone?
10 milliliters.
10 milliliter, right? This is a simple case, so it's 10 milliliter. Now, if my iodide is 0.200 molarity, and my silver concentration is still the same, how much silver will you need for reaching the equivalence point? 20 milliliter, okay? All right, so let's just use this as an example. We know that to reach equivalence point, we will be needing 20 milliliter, which means that the volume you have to add at equilibrium will be 20 milliliter. And we always use VE to represent the volume of titrant you will be needed to reach equivalence point, okay? And the way of defining before, add, and after is the volume you added, right? So in this case, the volume you added should be smaller than VE. This one equals to VE. And this one should be larger than VE, okay? All right, now, if we go back to the first case, before the equivalence point, it means that you didn't add enough silver to the solution, so you will still have plenty amount of iodide in the solution. How do you calculate the remaining amount of iodide in the solution? Let's take this one as an example and assume that we added 5 milliliter, okay? Well, the VE should be 20, okay? But in this case, we added 5 milliliter, right? The original concentration of the solution of the analyte is 0.200 molarity, okay? Now, what is the fraction of remaining? Now, think about it. If you need all the analyte to be reacted, you will need 20 milliliter, right? But you actually only added 5 milliliter. And how much is remaining? It will be 20 subtract by 5, right? So this is the fraction of remaining. You are using VE subtract by V add. Because the added amount react with the analyte. And the remaining amount is that part that didn't react, right? So you just look for the difference between the targeted amount subtract by the amount you added. The targeted amount is 20 milliliter if you want all the analyte to be reacted. But if we only added 5, you still need 15 more, right? So that's the 15, which is the fraction of, which is the remaining part. And you will divide it by the total volume that is required. That is the fraction of remaining. Okay. So
this is for iodide, right?
I'm sorry?
This is for iodide, right? We're calculating
this is for iodide, yes. Iodide. So for example, in this case, we added 5 milliliter. It means that 1/4 of the analyte is being reacted. And that makes 3/4 of the analyte still remain in the solution. So the fraction remaining is 20 minus 5 divided by 20, which is 3/4, right?
Why wouldn't?
Now,
Oh, quick question. Why wouldn't the volume, the VE, be 10 milliliters? Because that's how much you need of, that's how much you have for the iodide.
Well, the VE is the amount of amount of titration you will need for reaching
okay.
the equilibrium, right? You need 20
Oh,
milliliter to react with all the analyte, but you only added
yeah.
5. So that
Mhm.
means that only 1/4 is reacted, and you still need
Oh,
3/4 remaining. And then you also have to consider that the volume of the solution actually changed. Originally, we have 10 milliliter of iodide sample solution, but because we added 5 milliliter of titrant, so there's a dilution factor. This is the original volume, and the dilution factor is the original volume plus the volume you added, which will be 5 milliliter. Okay, so this is your original volume, and this is your V add. Okay, that's how you calculate the concentration of the analyte. And once you get the concentration of the analyte, the silver ion will just be the KSP divided by iodide ion. Okay, any questions so far? No, okay. Well, the second case is easier because we know that they are the same at the equivalence point. So this case, you just take the square root of KSP. Okay. And then after equivalence point, you actually have reacted off all the analyte. Now you're adding more and more titrant. So as a result, you have excess amount of titrant in the solution. And to calculate the concentration of the titrant remaining in the solution, you will use the original concentration of the titrant, which is 0.1 in this case. And then the volume in excess. What does it mean? So it means that you only need 20 milliliter of titrant to finish the titration, but you added more. So what is more there will be the volume of excess. So for example, if we added 25 milliliter, then the volume in excess will be 25 subtract by 20, which is the volume in excess, right? And then what is the total volume in this case? Anyone?
Is it 40?
How do you get 40?
Or I'm sorry, you're adding 20. You're adding everything in, so 20.
No, I actually added 25, right? So I added 25 into the solution. What is the original volume of the solution? It's the iodide part, right? Yes, so originally it's 10, and we added 25. Now the total volume is 35, okay? Make sense? And then in most cases, we are looking for PAG, and we know that PAG is negative logarithm of silver concentration, right? So whatever the concentration you get from here, you take the negative logarithm to do PAG, okay?